Okay, here's a thought experiment for you. How would you build a modern, high-tech economy from scratch in one of the most remote places on the planet? And I'm not talking about just, a little bit of power or a few new jobs. I mean a truly self-sufficient engine for growth. Well, believe it or not, one project is trying to do exactly that, and their blueprint, it's pretty fascinating.
Yeah, the vision here is way bigger than just putting up a few buildings. You have to imagine creating an entire industrial park that generates its own power, its own internet, its own intelligence, all of it completely off-grid, totally independent.
And that ambitious answer, that blueprint for what they call sovereign development, is Project Umoja Kaabong.
All right, so what is this thing exactly? Let's dive into the vision for this new kind of place they're calling a Smart Eco-Industrial Park, or SEIP for short. And it's all happening in Uganda.
And when I say the scale is ambitious, I mean it. We're talking 7,000 acres, a $30 million investment. The goal? To generate its own power and create up to 2,500 local jobs. But the real secret sauce, the thing that makes this whole model tick, is the commitment to a circular, zero-waste economy. Okay, so to make a vision like this a reality, you've got to start with the most basic problem, right? You need power, a reliable, independent source of energy. And that is pillar one.
The core tech they're using here is something called plasma gasification. And it's really cool. Instead of just burning waste, which is, inefficient and dirty, this process uses ridiculously high temperatures to basically unmake it. It breaks waste down into this clean, super valuable fuel called syngas.
And check this out. This is how that tech creates this perfect, zero-waste loop. It's brilliant. First, they grow industrial hemp. Then, after they process the valuable stuff, all that leftover biomass, the waste, gets fed into the plasma gasifier. That creates the syngas that generates all the electricity. But here's the really elegant part. A byproduct of this whole thing, called biochar, goes right back into the soil, making the next crop even better. So the farm feeds the power plant, and the power plant, it feeds the farm right back. It's a perfect circle.
And what's the result of that beautiful loop? 10 to 11 megawatts of clean, stable power. That is more than enough to power the entire industrial park and the community around it. All of it, completely off-grid. We're talking total energy sovereignty.
Okay, so power problem solved. You've got the foundation. But if you want to build a truly modern economy, you need a second pillar, and it's just as critical. You need world-class digital infrastructure.
And this is where the project gets its intelligence. They're building their own high-performance data center, and they call it the Umoja Compute Core. And look, this isn't just for checking emails. This thing is the digital brain and the main economic engine for the entire park. And just get a load of the hardware they're putting in here. We're talking 250 high-density servers. They're packed with over 1,000 of the most powerful GPUs on the market. That is some serious supercomputing power, enough to chew through massive data sets, plus 10 petabytes of super-fast storage. I mean, let's be clear, this is a globally competitive, top-tier data center, and they're building it in the middle of Kaabong. It's wild. Of course, all that computing power is pretty useless if you can't connect to it, right? So the entire 7,000-acre campus, from the sensors out in the fields to the data center itself, is covered by a tough Wi-Fi network, and it's all hooked up to the rest of the world with a high-speed Starlink connection.
So, that brings us to the real payoff question, doesn't it? When you have your own power and your own supercomputer, what can you actually do with that? What kind of doors does that kind of independence actually unlock?
Well, the range of what's possible is just incredible. On one hand, you can run the most advanced, high-tech farming imaginable right there on site, using AI to get the most out of every single plant. And on the other hand, you have the raw computing horsepower to become a global player in something like high-value data science, processing these crazy complex 3D models for clients anywhere on Earth.
In that mining example, it's a perfect look at the business model. You see, processing geophysical survey data is this hugely complex job that takes a ton of computing power, exactly the kind they're building. So by offering that as a service to companies around the world, the park can tap into a multi-billion-dollar global industry. It turns their infrastructure into a massive source of revenue.
But the ambition doesn't stop there. I mean, once you have guaranteed power and a fast, campus-wide network, you've basically created the perfect sandbox to develop and test some really next-generation tech. We're talking about things that sound like they're straight out of science fiction, like a fleet of rugged, autonomous electric vehicles they're calling Kaabong cars.
It actually becomes possible. Okay, I know what you're probably thinking. This all sounds incredibly ambitious. And you're right, it is. So how on earth do you pull it off? How do you de-risk a project this massive and make it a model that other people could copy? What's the secret sauce?
Well, it starts with this amazing line from their strategic plan. The instruction manual is just one sentence. Put it in the sun. And that simple idea, it points to the key piece of tech that makes this whole thing possible right from day one.
It's called the RIOS Pilot Command Center. And the best way to think about it is infrastructure in a box. Seriously, it's a shipping container that you can drop anywhere. And the second it's in the sun, boom, you've got solar power, you've got satellite internet, and you have a secure base to work from. It completely solves that classic chicken and egg problem of how do we build stuff in the middle of nowhere if there's no power or internet to begin with?
So with that command center as the first step, the whole project can roll out in these really smart logical phases. In year 1, you secure the site and power it up with that solar box. By year 2, you've got a smaller 1 megawatt bridge power plant going, enough to handle major construction. Year 3, the park's own microgrid is up and running. And by year 5, the big kahuna, the main 10 megawatt plant is fully operational and the whole vision is real. It's a smart step-by-step way to do it that manages the risk.
Which really brings us to the final and maybe most important question. By putting the most essential infrastructure, power and data, on the ground on day 1, before a single other thing is built, has this project created a whole new blueprint? Could this self-sufficient, infrastructure-first model be the future of sustainable development all over the world? And what does it really mean when the tools to do this kind of thing become available to anyone, anywhere?